themselves. Danique is the founder of STEM Lazy and Learning Academy. And he's the one that brought me into this, and he's always bringing me into things. Okay? All right. Loud.
My name is Anthony Porter. I'm a part of the Sigma Beta Club of West Palm Beach. I am a crisis intervention teacher at Yankee Middle School.
Can you hear him?
Good morning, Anthony. Good afternoon. Good to meet you, sir.
Nice to meet you too.
You just talk a little slower or something. Next.
My name is Conrad Jones. I'm also a part of Sigma Beta Club. I'm also a science teacher, 7th grade, John F. Kennedy Middle School.
Good morning, sir. Good to meet you. Good afternoon. Good to meet you as well.
Go ahead.
My name is New Samad. I'm with Miss Estella Brilliant Bus. I help her with Brilliant Bus. I'm engineering technology is my field. So I'm working with her towards that.
Good to meet you. What was your name again?
New, N-U-H Samad, S-A-M-A-D.
Oh, New Samad. Good to meet you, sir.
Samad.
Good to meet you, sir.
Good to meet you as well.
Okay. Hi, Manuela. We spoke briefly on the phone yesterday with the Boys and Girls Club. I work with team programming through all of our Palm Beach County sites.
Good to meet you as well.
Yes, how are you? My name is Anthony. I'm with Florida State Christian Academy. I run a makerspace, and I work together on Robotics with Jack. We're in another makerspace that was in Fort Pierce, Florida.
Wait a minute, Jack. I remember Jack. Yeah.
Jack, you
How you been a little while, Tariq? How you doing, sir?
Hey, Jack. How are you?
All right. Trying to put this thing together and new ventures, new days, and look forward to making something happen here.
Absolutely.
very diverse group.
Yes.
And we're supposed to have a lady involved. And I just want to say before we really get started, the weather is bad here, Tariq. And everybody who was supposed to show up, showed up, and I'm impressed.
Wow. Well, I am happy to be in your company today, and we got a jam-packed session, and the goal is to get you comfortable with delivering underwater robotics to the young people, the families, and the communities that you serve. I will note that the approach that we want to apply is it's a 2-gen model, and the reason why is simple. And then we'll start after this. The little boy or the little girls that we work with, they're going to go home to their parents, and the conversation might say something like this: "Hey mom, hey dad, today I learned about fulcrum." The parent's response can't be, "You mean fork, sweetheart? You learned about fork?" That can't happen. And so with this concept that we have, we just have to make sure that we are being diligent to not leave parents out of the conversation, to bring them into the equation, and to show them how to support the kids. And we'll get to that as we navigate through. All right, so I want to welcome everybody to Underwater Robotics 101. Yay! And the way that I have this set up is 4 segments. We use a pedagogy teaching concept where we're rolling off of 4 things. The first part, which is what we're going to do in a moment, is called Some Assembly Required. Some Assembly Required. The second part that we'll do has to do with making the connections. Making the connections. The next part after making the connection, after we make the connections, then we move into what we call,
Hold on 1 second. I got an alarm going off in the garage. It's hard to hear right now. Bear with this.
No problem.
Where's number 2?
Making the connection.
Making the connection.
Sorry about that. You want us need a tablet?
Yeah, let me see one too, sister. Thank you.
You need one?
No, I got one, thank you.
Okay.
She knows.
Right down here.
Thank you.
And after we get through with number 2, I'm gonna just move this to the side for a moment. After we navigate through number 2, which is making the connections, then we move into fine tuning. Fine tuning. And after we're done with fine tuning, the last concept that we touch on is the most important, which is noun presenting. Noun presenting. Okay. And the reason why we do it this way is fundamentally kids can relate to every part of what we have. So some assembly required is really exactly what it says. Things have to be put together. And so this is the end result of what we should have today. Now, this has a few pieces to it. I won't get into the names of what these pieces are. I just want to show you what a finished ROV could look like. Now, this is a very basic ROV. Nothing fancy here, just very basic. Very basic. And the complexity of it depends on where the students are, where the teams are creatively. But this is the very basic one to build. And so we'll attempt to build something that looks like this, or you'll attempt to put one together on your own. Now, candidly, the pieces that you have, and I'll tell you what I mean by pieces, the pieces of PVC that you have probably don't look like mine's. And so they're probably a little longer. You probably have 10-inch pieces or 7.5-inch pieces, pretty long pieces. But the pieces that I'm using are actually measured and cut already to give me a desired outcome. So this is where we encourage the students to get creative, to explore a little bit, and then we just put a time frame on that because we don't want to run away and get caught up with timing with this. And so I'm going to just put an ROV together using, you can see over here, let me move this out of the way. Again, I'm not sure how your stations are set up there in Florida, but if you have PVC, it doesn't matter how long your PVC pieces are, you can actually do some of what I'm gonna do right now. So I'm gonna just go over a couple of the PVC pieces. So this is this piece right here, this would be a T piece of PVC. This would be a cross piece. This will be a 90-degree left and right angle. This allows for 3 different connections to happen at once. And the last piece that we have is, now this is a custom piece. So this piece that I have here, you should have this. This piece is specifically designed for the motors. So it's just the motor casing. But when we get to the point of putting this together, we'll actually have a different name for that. But these are essentially the PVC pieces that you have. Now, you may have a 90-degree piece that only has one connector. So you may have something that looks like this only. This piece that I have I can plug in 2 different pieces from any one of the angle plus another piece on the top. You may or may not have that piece. Whether you have it or not doesn't really matter. You just have to get creative on how you connect your pieces. So even if you just have the one elbow, which let's see, we don't actually have just a single elbow piece. But if you just have a piece that just has one elbow, it's going to do the same thing. So what I'm going to do, and I encourage you to do the same thing on your end, is to just try without a whole lot of instruction, because this is what you want. You want to see what kids can come up with on their own, using their own creativity. Because after all, it's their underwater robot. The judges that will be asking them the questions are going to ask them, who helped you build that? And kids will tell on you. Oh, Mr. So-and-so or Mrs. Such and such helped me build that. They will tell on you. So giving them the creativity to build it within the parameters of time to just kind of explore and get it moving on their own is a very good thing to do. So if you have questions, I'll take your questions as I'm building this. But my goal is I'm going to take all this little stuff that you see here, PVC, and I'm going to put together a basic ROV without the motors. I'm just going to build the frame. I'm not adding motors or anything else. I'm just building the frame of it, and then we can come back and add the motors But right now, the first part that we're dealing with is some assembly required, putting something together.
So while we're building this, are we using PVC or anything to keep them together, or
That's
no?
a great.
Because the water, it depends on the glue you use whether or not it's going to stay together or not. So
That's a great question. So the really cool thing about PVC is this. Typically, so this is in every. So how I make the connections, and some of it overlaps. So the now presenting happens simultaneously through every piece. The fine tuning happens after really everything else, and sometimes making a connection and some assembly required go hand in hand. So let me make the connection for you with this. So in almost all the homes in the United States, they have PVC, and so we tell them polyvinyl carbonate piping that carries water through it. And so to put this together, to make it do what we need to do as an underwater robot, we just hand tighten. So we take it and we just put it together, and that's it. We're not using any type of plumber, cement, or anything. This doesn't require that for what we're using it for. So I'm gonna go through and build something very quick. And what I'm doing is, I'm gonna build it. You'll see how this comes together right now. I'm building the front part of it. And so I already know what I want this to look like. So this is my first side, and then I'm gonna get another one that looks just like that. So I have the same pieces. And so essentially what I have is one side of it and another side of it. Now I need this to come together, so I'm gonna just play around with a few other extra pieces here. So I'm gonna take this piece here. I'm gonna find another small piece that's similar in size. We didn't leave any pieces off, did we? Because this looks like I might be missing a piece or two. Okay, no problem. So I'm gonna take this. I'm gonna go here, and now I'm gonna take this piece here in the middle. And now I have a top part of the ROV. This is the front part of the ROV, just the front portion. So with that now, I'm gonna build the side out. I'm gonna tell you to build the side out. This will be the front, and now I'm gonna try to build the side. Or actually, this will be the back of it. So I'm gonna actually build the side out. And so my side might look like this. Here's one piece over here. Here'll be another piece. And then what I need to finish this piece out. So I know I wanna have something that will go like this. So I'm gonna take these two pieces. So now if you look at what I got here, it may be a little hard to see it, but what I'm gonna end up with is this little section right here is actually gonna to support a motor. So I'm gonna make this last connection here. And then if I go back and tweak this now, like this. I'm gonna end up with what will essentially become something that's holding my motor in the middle. So you see how that's coming together? Now, literally, now there is a website that I will share out with you. This is being recorded, by the way, so you can go back and rewind as many times. There is a website from my alma mater, MIT, where there's a basic underwater robot kit that will just walk you through building a really basic kit. It's real basic and to the point, so I'll share that out in the resource link on a resource link once this is all done. So don't worry about, oh my God, he's moving too fast or I don't quite get it. There is a video that will show you how to measure, how to cut specific pieces for a particular type of ROV. But again, this is where you want to encourage your students to be creative. So now I'm just going to finish out this side here. I know that I need to have a motor over here. So here's what I'm going to end up with. This is one side with the motor. I'm going to add this piece right here in the middle. This will be another motor. You can see how this is coming together. And now I'm going to finish out this side very quickly. And I want to come up, since I know I need this to happen over here. You can see how this all came together in that little bit of time. I have a side of it built already. I have a motor, another motor in the middle, and now I just need to finish out the back or the front of it. And so I'm literally just doing the same thing that you saw a moment ago. Taking these pieces. Here is one side of it. And I want to cross-reference this now to the back, so the back and the front look the same. And I want to have something maybe that goes out, and so this piece in the front will be something that I would attach something that I need to be able to pick something up, and we'll get to that, what that is in a minute, once I have this built. And so now I pretty much have a side of it built already. And I'm gonna just keep going because this side is done. Now I just need the other side to be done. So if I turn this side isn't done, so I'm just gonna finish that side out. I know I need that. I know I'm gonna need another one of these to go up. And I know I'm gonna need this piece here. I need another piece to make that connection. And then I wanna close this end off here. So that will allow me to close it off now. Here's the side, and I'm almost done here. I just need another motor to be on this side. So I'm literally taking this whole thing and just putting another one on that other side. Now again, my pieces are already pre-cut because I already knew what I wanted this to look. And so now, here's my other motor on this side. And so when you look at it from the front, or from the top, you can actually see motor, and we'll get into the terminology later. I have a motor here, and a motor in the middle. And the last thing that I want to do is, I want to take this and put that together. This pretty much is my frame. Now that took 10, 15 minutes to put together, but before I was able to get 10 to 15 minutes, I came up with a lot of sketches on where I wanted and how I wanted things to look. And that's where, before anything has to be built, you want to encourage your students to draw and sketch out before they start cutting. And we call that measure twice, cut once. Because this PVC, that pipe that you have, you don't have an unlimited supply of it. Now, you could go to any of the Home Depot and local home supply or utility supply stores to get this stuff, but why run out and get it? One of the things that we encourage students to do, because when they see it, they think they got an unlimited supply. We tell them do more with less, or be lean. And so this is what I came up with. And then the only thing that would be missing here, I'm gonna step off screen just for a second to just show you another part that would be missing from this. Would be some pool noodle to add some buoyancy to it. And this is where again you're gonna see kids go crazy over this. This can be pink, green, orange, rainbow. You can spray paint it. You can do a number of different things with it. It doesn't have to be a solid color, including the frame. So one of the things that we encourage our kids to do is to really get creative. And so, last year they had one side was blue, the other side was yellow, red. Just get creative with it because it's spray paint. And once we go through the process of priming it and then painting it, the chlorine won't affect it when it's in the water. All right. So this is what you'll end up with as a basic ROV frame. ROV frame. So we just finished the first part of some assembly required. Does anyone have any questions?
You recommend spray painting after you put it together, correct?
Yeah, so one of the last things that you'll do so after this is all built, if you want your students to be creative and really take some ownership of their project, you can spray paint this. Now, you can also buy the PVC in different colors. It's very expensive, but a can of spray paint is $7 opposed to one 5-foot piece of PVC, which is like $12, that you probably would get a few pieces out of. So if you are going to spray paint it, what I've seen work very well is first you have to prime this with primer. Once you prime it, then you just spray paint it, and then they have it's like it's not shellac, but it's like a shellac type of thing. It's another coating that you put over it to protect it from chlorine. But I wouldn't spray and do any of that until I've had the frame built and before I put the motors on. Before you start adding any other thing, you want to make sure it's sprayed. You got a good design first before you start adding motors because, well, obviously if you spray paint it with the motors and everything on, everything's going to get painted. So.
What kind of motors are you using?
Yep. So we'll get to the motors in a minute. We're using these XPS Johnson pump motors. These are 500 GPH motors. So these motors can be used on fishing boats, and we talk about these. But these motors now, you can use a different type of motor. They cost more money, and honestly, these are going to work for what you need and the type of control that you want to have. Could you go out and get an 800 GPH motor? Sure, you could. But this 500 and this is going to do the job for you. And if you one of the requirements next year for the event is that you have to keep a list of any extra supplies that you have that enhance your machine. Kind of like going through compliance. So when you go through a compliance check, one of the things that they're looking for is, did you use stock parts? And if you didn't use stock parts, then you have to report out on the sheet the additional pieces that you need to enhance the performance of your ROV.
Can no motors go forward and backwards?
Yeah, so all these motors, so the short answer is yes. What determines the direction that the motors go is electricity, the current, and how we hook that up, which we'll get into once we get into the control system.
That's good, thank you.
You're welcome. All right, so this is a basic ROV frame. This frame is done. And at this point, everything that I'm gonna do to this frame is just gonna be hand tightening. It's just gonna be hand tightening. I don't need any glue or anything. And I want it to be the same on all sides. And here's an opportunity to use mathematical terms, asymmetrical, so it's the same on both sides. It balances out, and if you look at what I have, this is not wobbly. I can place it on any side, and I'm not gonna get any movement out of this. This is a very well constructed frame. No matter what side I put it on, it's not gonna be wobbly, and that's what you want. Okay, you guys good?
Yep.
Okay, Perfect. So the next thing we're going to get into, which is still some assembly required, we have to figure out where we want. Now I have my notes electronically, so if you see me going back and forth, I'm looking at my notes electronically.
Tyree, I'm just curious. Is there gonna be any camera?
So this ROV, this angelfish ROV that we're building. So let me talk about this very quickly. So there are a number of different ROVs that can be built. The frame and the shape of the ROV doesn't change until you get into what's called a triggerfish. And a triggerfish frame basically is a vector. So by default, this frame right here will be for an angelfish or a puffer fish. You could also use this for a triggerfish.
All that I can share with you.
And there are, so there's an angelfish, which is the easiest one, pufferfish, triggerfish, barracuda, and there's another one that was just added that they're still perfecting. The most difficult one is the barracuda, and the last one that they just added. The easiest one is the angelfish, and I'll show you the differences between them as we start going through. But to answer your question about the camera, the angelfish wouldn't have a camera on it because the mission for the angelfish wouldn't require you to use a camera. The mission for the pufferfish would require you to use a camera. The mission for the triggerfish would require you to use a camera. And for sure, the mission for the barracuda would require you to use a camera. But the angelfish, by mission, and then we'll talk about the different classes of where these fit into for the competition. But this general frame wouldn't have a camera as an angelfish. If I was using this for a triggerfish, then I would add a camera to this, yes.
Oh, thank you.
You're welcome. All right, so I'm gonna take my frame and just set it to the side for a moment. And the next concept that we need to get through is has to do with this control box. So I'm gonna just make a small adjustment. Bear with me. So the control box comes like this. Here's what it. You have this already. Now you probably don't. So you either have the angelfish already taped on, or you have to tape it on. But here's what it comes with. Here's what it looks like without anything connected to it. This is the front of it. This is the back of it, and it's just the general case. Now, if the case is closed, which it probably is, then you should have a screwdriver that looks something like this or a little smaller. You simply just unscrew the screws, and again, any opportunity to deploy teachable moment and strategies with the students, so righty-tighty, lefty-loosey, it's a good thing to remember, or clockwise, counterclockwise, always good to import those concepts because that's how the motors propel or rotate. So once you open your frame and you get your case and you dump everything out, here's what you'll have. It's just empty. Now, to get started, the next thing that we would have to do is we need to create the power wires that go inside. And so here's what power wires look like. So in your bag, you probably have something that looks like this. You have something that looks like this in a plastic like Ziploc bag. This is your power kit. Okay, I'm gonna go over a couple of pieces for this. So this is what we call, this whole concept is what we call an inline fuse, because the fuse is in the line. And this case is what we call a blade fuse holder. It's a blade fuse holder. Okay, and this is actually already finished. Yours probably doesn't look exactly like that. You probably have this piece by itself and then the other pieces by itself. whether it's together or apart, the general concept is the same. This is what's going to give the controls, the power system. This is where we're going to get the power wires from. So the last thing that you want to do is take a fuse, and here's our blade fuse. And this type of fuse, this is a 10 amp fuse, same type of fuse that we'll find in a car. Well, most cars may have these still. I'm sure they still use them. But this is the last thing that will go inside. So the very first thing, and then we look at the top part of it. Now you probably have yours. I'm going to put mine back together so you can see it. We get this all the time. So I'm going to take this and connect it back. Here is how these two power pole connectors, this is how they look. They're together at the top. Can you guys see that? Can everybody see that?
Yes.
Students are struggling like, how do we get this apart? It won't come apart. Well, you just have to slide up and pull apart. That's how you get these two pieces disconnected. The reason why this is important is, now the power supply I'm using is this. This is not the power supply that you'll be using. But if you look at your power supply, you have a positive connector and a negative connector, and they're not right next to each other. And so if you leave these wires stuck together, well, you're going to have a problem making the connection. That's why we pull these apart. So one goes to the positive, one goes to the negative. Okay? So we want to go through and actually start getting this done. All right, so I'm going to cut my wires so you can see exactly what I have here. All right. So I'm going to cut this. It's already built, but I'm going to cut it. And this is more than likely what you have. It was already together as one wire. I cut it. And so what I did first is I actually measured. Just imagine that this whole wire is like yours, already to one piece. I'm going to measure using centimeters. I'm going to measure 8 inches of centimeter on the red side. And I'm going to use my Sharpie. Once I get my 8 centimeters, I'm going to mark it. And then I cut. And that's what I ended up with, this. So just imagine that this was one wire. I cut it. And now I have this 2 pieces right here. Okay? But now I need to get this back together. And so the next thing I need to do is I'm going to take from this end and from this end, I'm going to measure 1.5 centimeters. 1.5 centimeters. Measure on that side. I'm going to take the same thing on this side. And I have it marked. And the next thing I have to do is I have to locate the tools that allow me to. So what I'm actually doing is I need to strip these wires. Not cutting the wires, I'm stripping the wires. And so there are a number of tools that you have. So if you look at what I have here, these are wire strippers. But this can also cut wires. And there are different versions of these. This I wouldn't use for that because these are vice grip and these are crimpers. But I could potentially use this as well, but I like to have 2 separate tools that I know. Could I use this to do the same thing I want to do? Yes. But this actually is going to get me for what I need to. This is going to be better for me. Now, there are 2 pieces that you have to be, the 2 numbers you need to be aware of. If you look on these, you have numbers on the left that go from 10 to 18, and then you have numbers on the other side that go from 12 to 20. The difference is, looking at the very bottom, one side, the side that's from 10 to 18 is what we call solid. And the other side from 12 to 20 is what we call stranded. And here's how I get kids to remember the difference. A solid wire is just the wire, and I'm going to use this as an example. I'm going to come a little closer. Solid wire just looks like that. It's just solid. But if I take this and I play with it a little bit on the end, this becomes what we call frayed, spread out. And this would be what we call stranded. This is not what we want. We want this to be solid. So when our wire looks like that, we just twist it to make it solid. Go from stranded or frayed to solid. And so what I'm wanting to do now is I don't want to cut this wire. I need to strip this wire. By the way, what did I measure it at?
1.5.
Right, 1.5 centimeters. Thank you. And so what you want to do is, if you have two different sides of this that will essentially do the same thing, it's just a matter of your preference. Okay, because I don't want to cut this, I want to strip it. I already know that this is an 18 gauge, so I'm going to take this and put this in 12, because I don't want to cut it. And when I place it in 12, I'm going to just press down and pull off just like that. I'm going to come a little closer so you can see the other side, so you can see me do it with the other side. So here is my mark. This wire is a 12 gauge, 18 gauge wire. I'm going to take this and place it here in my 12 slot, because I'm not cutting it. I'm crimping it and I'm pulling down to strip the wire. Now, to avoid jerking it all back and forth, what I could also do is just crimp it enough and then use my fingernail to pull it. Don't let kids do this. You'd be surprised.
That's what they're gonna do.
They want to put everything.
Right. Don't let them do that. It does take some skill to get it, but once you get it, you got it. And that's what we got. Now, here's where it gets real interesting with kids. I need to marry these two colors, and I got two different colors, silver or copper and silver. These both need to go together now. Both of these pieces are gonna need to go together. The first step to getting this together is to just take it and simply twist. We twist, just a simple twist. And that's what this was before I put this plastic coating on it. But now I got the same thing that you saw a moment ago when it was all put together. I have the same thing. Now I have what I need. This is the same thing. This doesn't get anything done to it. This black piece would just remain a solid piece through and through. But here's what I got now. Okay? Now, the shrink wrapping is important. You have a number of different shrink wraps. All of them are black. So I'm going to go backwards to just show you what that would look like. So before I actually shrink wrap this onto here or put this together, I would take my shrink wrap. Now, I don't have any extra shrink wrap. I don't think I have any extra. See if we have I think I see a piece on that right here. This whole piece right here. Yeah, I do have an extra piece of shrink wrap. So here's an example of what I'm talking about. So here's my shrink wrap piece. So I would take this shrink wrap place it on one end. Like that. Then I make my connecting to my wires. Now this wire has to be soldered. This has to be soldered. We won't be soldering today, but this has to be soldered. And once this is soldered, this goes over here like this. And then I shrink wrap that wire just like this was. And then I get this whole piece protected. Okay. Does anybody have any questions? All right. So now that we have that shrink wrap done, we have our final result in our wire. Final result. The only thing that's missing is what you don't see over here on this side is the other part of that wire. It's just this whole wire would be, the other end will look just like that. The black wire, we didn't do anything to the black wire. It would just look just like this. Just like that. All we did was we modified the red side of the wire so we could marry those two pieces together to make it longer, because we needed to be longer, and we got to have a fuse in that line, which we'll get to later. But this will be the end result of that. We've just finished. Congratulations if you got this far. Then we just finished creating our power cables, power wires. That's what we just did. We created our power wires. The next thing we need to do, which is the coolest part, we need to create the control system for the angelfish. So I'm going to put this to the side. Now the control system has a couple of pieces to it. Once you take your control box apart, you're going to have 3 of these. 1, 2, 3. We'll talk about the names a little bit later. By the way, we are still in some assembly required. But notice, because we're putting things together, we are also making the connections. So we have 3 of those. We have a bag of these, which I'll talk about in a moment. Some of them are red, like this. Some of them are blue. We'll talk about the names of those in a minute, like that. And in the bag, because these are all going to be in the bag, we should have 3 of these. They look like that. We also have a number of these. These are all little pieces in the bag. These little rings that look like this. And what may not be apparently obvious is this other little one that's already on here. But this actually, this little other piece. So on the switch, and we'll talk about what kind of switch this is in a moment, there's another little ring on top of it. Okay. All right. All right. The type of switch that this is what we call a DP DT. So David, Paul, David, Tango. And what that means is this is a double pole, double throw switch. That's what the DP DT means. And all it means is throwing is an engineering electrical term. That means we don't actually throw anything, but we technically in engineering, electrical engineer, we throw by putting in a different direction. So that's what we mean by throwing. It's just switching. So this is a double pole, double throw switch. that allows us to switch this in any or throw in either direction. 2 poles, one in this way, one in that way. Now, when it's not in this position or this position, it's in the neutral position by default. Okay? These pieces that we have here, these are what we call terminal ring connectors. And I'm gonna get a little closer, so I want you to see what it looks like. So this is a red terminal ring connector. This is a blue terminal ring connector. Now these are what we call 14 gauge to 16 gauge ring connectors that have to do with the type of wire that we're using. And what we mean by wire, now your wire that you have is yellow. Looks like this, but it's in the spindle. It's not separated yet. It's in a long spindle, and that's what it actually looks like. The wire that I'm going to be using is this black wire, maybe. But even if I don't use this, if it's black, if it's red, if it's purple, if it's green, doesn't matter as long as it's the right gauge of wire that we need. Because what you'll find is students are going to crimp and cut these wires. You should plan to have an extra spindle of wire. I found that students, for whatever reason, they like to cut up the wires. Don't ask me why, but they do. And so having some extra wire is going to be a really good idea, a good strategy. All right. So we're going to actually go through the process of putting this together now. So this little piece that we have that says on and off, this is what we call a face plate. And if you look at your face plate, it has, I'm going to get a little closer. If you look at your face plate, it has like a little tooth on the top, right there. And that little tooth on the top is because on your switch, there's a little notch of where it goes. And if you look on the other side, you don't have that little notch on this side. You have it on this side. Okay? So that's why we have that little tooth right there. All right, so we're gonna get this built first. So the first thing we're gonna need to do is we want to make sure that we have the cover, and we want to have 2 things. So once you take all of your pieces off of your double pole, double throw switch, you want to make sure that you have the nut at the bottom, leave that one on, or if it's not on, make sure you have one on. So here's what I have. I'm going to start literally from scratch. Right now, my double pole, double throw switch doesn't have anything on it. Nothing. So the first thing I want to do is I want to take my nut and I want to place this over it. So this goes on like that. Just like that. Next thing I need to do is I need to find my faceplate. And I'm going to position my faceplate with the tooth on the right side so it slides right over gently, just like that. Now, the piece that I'm missing is this. So this can go in either one. This doesn't matter which one we put these in yet. So if I put this one here, it doesn't matter because I'm going to end up with 3 of these anyway. So I'm going to take this and place this inside my plastic cover. I'm going to find my faceplate and place my faceplate over it like this. And then I'm going to find the other nut and I'm going to place that over top of that. And here's what I end up with. That's the first one. Now, when you're putting your teams together, what I found to be a really good practice or a good strategy is this propulsion system that we're putting together, or this control box system, this is being done by a team that only does the control box system. That's it. They don't do anything else. I had another team that put the frame together. They came up with the frame design. That was their job. Come up with a frame design, something that's going to work to accomplish a task. That's it. That's all they're doing. Researching frames, researching designs, possible ideas. That's all that they do. The other people who are putting this together, this is all that they're doing. Now, candidly, you may have the same people or persons doing this, finishing that, and then moving to this, and that's fine. But what's a really good practice is to have kids doing separate things, even if they're contributing at the end of it. Because candidly, as the team, one person shouldn't be doing everything. So now that I have this put together, I'm going to take this very same thing. So I'm going to literally just start over. So I'm going to show you everything from scratch. Right now I have my, you guys remember what this is called?
The double throw switch?
Double pole, double throw switch. Yes. DT switch. Yeah, double pole, double throw. The reason why I say that is because there is a double pole switch. But there's a double pole, double throw switch as well, and that's what this is. So once I get that, I'm going to take my nut right here, place this over top of that, just like this. Again, it doesn't matter which one I place it in. It also doesn't really matter the direction yet. We'll talk about that as we go through. Now, the new double pole, double throw switches that you have, they look a little bit different, but we'll get into that in a moment. So I'm going to take this and place this inside. I'm going to look for my face plate. And I'm going to look for the tooth opening, place that down. I'm going to look for my nut, put this on top, hand tighten. And now I have two of them. And I'm going to build the last one. Same thing. I had this piece right here. So I have my double pole, double throw switch. Then I take a nut, I place the nut on top of it, hand tighten that down, look for my face plate. I place this inside. Doesn't matter which direction, it's gonna all do the same thing. And I look for my piece here. This goes over top. And I'm just hand tightening. And here we go. Here's what I end up with. Okay. All right. The next thing I need to do is that yellow spindle of wire that you have, you're going to need to crimp out or cut out, let me see, I think we're doing 8 of these. 1, 2, let me count again. 1, 2, 3, 4, 5, 6. Yeah, we're going to cut out 6 different wires, but here's how we get to the 6. I'm going to use this as an example. We're going to measure 6.5 centimeters. 6.5 centimeters. And once I get my 6.5 centimeters, I'm going to mark each wire. And I'm using my cutter. So I'm going to cut. I'm going to end up with 6 of these. So that's 1. I'm measuring and cutting. 2.
Everybody alone pretty. No.
Yes.
3.
question I expected to remember all of this, because you have
4,
go step.
5, 6. So here are my 6 different wires that I'm going to need. My 6 different wires. One of the things that you also should stress with your students is that when they're done using tools like this, close it and lock it back so it's not open like this. So once I close it, once I'm done using it, I just close it and lock it back so nobody pokes themselves or has any type of weird accident. I do the same thing with the markers. I'm not using it. I put the tip back on it. It's out of the way so nobody goes home with ink all over them or funny stuff. All right. So now that I have my 6 wires, the next thing I need to do is I need to cut off the end of 6 wires. I'm going to strip 0.75 centimeters, but I round that up and just say 1 centimeter. And so, because 0.75 may be hard for kids to get, especially if they're still learning math concepts. So I just round it up to 1 or half. And so what I'm going to do is, I rounded it. I just used a half, 0.5. And so I'm going to mark this wire, each of the ends. So each wire is going to get marked at 0.5 centimeters on each end. So I'm going to measure 0.5, 0.5. I'm going to do my other wires, same thing. 0.5, 0.5, 0.5, 0.5. So I'm using a half here. Yep. Okay. So now my wires are marked effectively. Let me look through my notes real quick. So the wire that I'm using, as I already mentioned, this is 18 gauge wire. And so if you go back to this, this tells me which gauge wire that I'm using. So this is not 10, so I wouldn't put it in the 10 slot. 18 is all the way at the top, and I need to know that because for this wire, I want to strip the exact amount off. I don't want to cut the wire. So if I put this wire in the wrong slot, I'm going to cut the wire. I don't want to cut it, I want to strip it. So I'm going to use this as an example. So I know where my half is. This is my 18 gauge wire. I'm going to press down. And again, I'm just stripping off the end of that wire. That's one end. I do the same thing to the other end. I'm going to end up with 6 wires that look like that when they're done. Okay? Now, one of the things you got to be really careful, and you can assign somebody to this job, you want to make sure that it's very easy to cut the wire, to cut the copper that's inside. What will happen is if the wire is cut or the copper is cut or if it's just damaged, it's going to affect voltage and it's going to affect ROV motor performance. So you really want to have, you can assign somebody as your quality control person. They're the person that goes and checks to make sure the wire is not cut or damaged or compromised or anything like that. And they just go around. If it is, don't use that wire because for sure you're going to get a short circuit. It won't. The end result will be your motor's not working. And you're trying to figure out why is it working. We measured and cut everything. Well, you didn't make sure that you didn't damage the wire on the inside. And it's real easy to do that. These wires are very fragile. So once we're done with that, here's what we have now. When we're done, we have 6 wires that all look like that on both sides.
And I guess somebody's on water or soda or something right now, or you let me know when, raise your hand and I'll
We're
do
about
it.
an hour in. All right, so here's what we'll do. So we're about an hour in. So we're going to pause for 5 minutes. The screen will keep rolling, but we're just going to pause for 5 minutes. So it's, let's see, what time is it? 1:55. So 1:55. So at 2 o'clock we'll come right back, and jump right back in.
Okay, everybody can get up and stretch, but I got a couple of questions I need to ask you.
Yeah.
When you look, it's come to them now. Not you, just talking to them. Obviously, everybody seems to be understanding, and we